Okay. I mean, copied, right? Okay, fine. So Vasudev, as you know, that Shita is not yet to be seen, so I presume that we should begin with a topic which is to fall next. And you're aware of the change in the schedule and the scheme which will be followed in the mains examination. Though we are not a position for mains, we'll be going beyond, no doubt about it. And we have to see that we go beyond during the preparation for mains. It's not that I am pre-barricading any preparation. It should be in wholesome done. So we are to see that by the end of February, we are through the mains as well as advanced examination portion, right? Yeah. So in advance, we do have communication as well. I'll see to it when we can take communication. I'll be taking post beat. First, we'll be indulging in the beats portion of wave, and then we'll go for the communication as they have got some relation. They are relatable to each other. In the case of beats, but for sure you're not done much. So what I'll do, I'll take beat first and then move for communication. But today, what is in agenda is to see for we are through certain portion of modern physics. So are you in concurrence with it?
So modern physics, they have finished it in Alan, but it was quite haphazard. I personally have not like rigorously studied it yet.
Photoelectric effect did they touch?
No, not about the photoelectric effect. I mean, just as much as I know from chemistry, from atomic structure. It's about the same thing, right?
Okay. So what I should do, I should begin with photoelectric effect and the reason for why do we change from waves to particles. Yeah. So what is the reason to change from waves to particle? What are the phenomena which are not juxtaposed with just a functioning of light as a wave? Okay, dear.
Yes, sir.
Okay. So let me begin with an experiment. But before of that, let me ask you, what comes to you when I am to propose that let's study light as wave? Then what compelled me to think about light as wave? Sorry, particle. What is the compulsion? Why can't we go with what we have till date study with light and that being waves? Why this departure? What was the observation we were not able to explain by assume related to or limited to light being waves? By this assume or assumption.
So is that the
What
question?
happened? What forces? What was the compelling? Yeah. What was the compelling need?
So from what I know, we just came across a few phenomena which we couldn't describe with the wave understanding of light. Primarily because with waves you get more of a gradual change in properties, right? But then when you come
Okay.
across phenomena like the photoelectric effect, they're very intrinsically discrete things that are that are going on. It's either there or it's not
Mhm.
there. It's kind of the difference between analog and digital, if you ask me. Like I like to draw
I
parallels.
think it's perfectly fine for me to understand what you're trying to suggest. I still will ask you to reveal more. What did we observe something is what you take, correct? You said that we made some observation based upon those observation. We got some insinuation and that we did carry forward, correct?
Yes.
So what exactly was it? Can you reveal more?
Oh, well,
If you're aware of.
the only thing that I
Hmm.
remember right now is the photoelectric effect.
And how is this an odd with waves, concept of waves?
Well, if you try to understand this using you understand the photoelectric effect using the wave model, you'd
Mhm.
expect the number and the energy of electron emission to scale proportionally with the intensity of
Okay.
the light being incident upon the metal, but that's not what happens, right? There's a very clear threshold which needs to be crossed before the electrons start coming out.
Okay. So that is based on work function. See, work function is nothing but let's say you are in a well, right?
Yes.
And you have got many a pebble. You are in a well, you have got many a pebble, and you what you want to do, you want these pebbles to surface. There's a well that I'm in. This well is of depth H. There are pebbles over here. I started throwing them one after the other. and
Yes.
I want them to surface. By surface, what I mean, I want this is my line of action or line of vision. This is my line of vision or line of action, whatever you say. Line of vision is better. So this is my line of vision. I want them to cross line of vision. When it crosses line of vision, any of the pebble will cross the line of vision. Then it will be recorded by the instrument of record. This is my instrument of record. It will record its presence. Let's
Okay.
say. So this graduation being done, one, two, three, four, will be able to record what is required for this wave, this particle to show. For this particle to show, the minimum energy required, as you are aware of, will be as per height or depth of well, and that being h. So mgh is the minimum energy required for the particle to show, correct?
Yes, sir.
If we provide mgh, can we ascertain presence of particle? Is it that by providing mgh, we are cementing its presence? We will be able to see, or we will make it show? Is it? Or still there is some lurking suspicion here and there, may not. Still, we are presumptuous about it. What say you? Is it perceptible or imperceptible?
So if the if your measuring device is fundamentally
Hmm.
limited by the laws of nature, then I'd say it's imperceptible, right? You can't see whether the rock is there or not until it attains that minimum energy.
Hmm. So MGH is being provided. That is what I said.
Yeah.
But it's myriad. You have myriads and you are into ad nauseum throw. Incessantly you are throwing. You're throwing them without any delay, just picking up and throwing off the bat, let's say. And
Okay.
in that case, what you expect? You are not looking, you are into, we are into, in a lunatic manner, throwing it with the helter skelter, nothing much.
All right.
So what we expect?
I don't
What we
see where like this is leading. I mean, sure, you'll see a lot of rocks coming out of the well,
exactly.
but
Yeah, yeah. You can read where I'm trying to lead it to, and you can accordingly position your answer. Tell me.
yeah, that's what I'm not able to do. I don't see where you're going with this.
Okay. So what is certainly not over here to cement is by providing MGH, I will be able to, or will be able to make it show. That is not in my capacity. I may say that yes, probability will certainly be high because whatever energy was required is being provided. So probability behind, no doubt about it. But at the same time, in the same breath, what I'm to say is it's not for me in any way to ascertain that the particle is to show. There will be must a show. And can you tell me why I'm caging about it? Why I'm having that inhibition? Why is that being carried? The preemption being carried that it should be. But that preemption I'm not at all banking on in toto. I have some inclination, and that inclination being, yes, it should show. Still, I am on purpose trying to stay short of commenting on there will be a show. Why so? Because it is being thrown ad nauseum. There is a possibility that when that particle which I'm throwing was moving up, it somehow did hit a particle which was on its backtrack, the return journey, correct?
Yeah.
So I may say that when that particle which I did throw second, first particle when it makes a hit, it loses the chance of show or crossing the line of vision. Yes or no?
Yes.
So had there been only one particle with me, were there only one particle with me, I would have but for sure said that this particle will cross or will touch line of vision if provided energy mgh or an iota more than a psi more than that, correct?
Yes.
But that is not the case. You have myriads, you have a sea, and the sea of pebbles certainly is marring the possibility or marring me from cementing my position, marring me from ascertaining you that yes, it is to make a show. I am not sure about it. I am carrying a supposition. Correct, dear?
Yes, sir.
Okay. This is what is for a metal known as work function. Correct, yeah? This is the work function. That means in a metal or an object which I'll be taking for reference, I'll be taking a metal, let's say, there is electron which is positioned somewhere beneath certain position of show or surface. Somewhere beneath I mean energy, on energy front. Are you getting it here? On energy front. If you
Yes.
want this electron to surface, if you want this electron to show, then you'll have to provide some energy, and that energy is related to characteristic. Over here, energy for this pebble to show is related to H, right? Yeah, M and G are intrinsic, correct?
Yes, sir.
So it is related to H. If it is related to H, what is H for the well? H is to define property of well. Can we say that?
Sure.
H is to define property of well, right? Yeah.
Yes, sir.
Similarly, when I want electron to show, I will have to provide the bare minimum energy. That bare minimum energy is subject to characteristic of metal that we have taken in reference or that we are experimenting on. Correct, dear? The one that we are experimenting on, right,
Yes, sir.
dear? Okay, if I'm able to provide that energy, which henceforth will be called work function and will be denoted by the term phi, work function. This is the minimum energy required for the electron to show, and this energy is what is being termed as the intrinsic property of material under study. If I provide this energy, I come to the most susceptible position for the electron to show. It in no way is to say that come what may, high water or hell, it is to show. Hell or high water, it is to show. I cannot be of that stouch a statement into making, which is it is to show, and you know the reason for it. As there are myriads of pebble in this well, there are myriads of electron in a conductor. So much so it tantamounts to 16 to 6.023 times per 23 for 1 centimeter cube of good conductor. Is it okay, dear? That high amount we cannot even conceive. That is the amount of electron that you are referring to. So there is a very high probability of they colliding with the other. Correct, dear?
Yes, sir, but I have one problem with this.
Yeah,
Uh,
yeah, tell
so,
me, tell me.
so you could apply that logic also to the work function itself. For example, you could say that phi is not the absolute minimum energy required. Maybe some electrons collide inside, and somehow one electron intrinsically gains the energy
Yes.
required to exit. Then you don't need to provide phi externally, right? So you can't
Yeah,
establish it
that
as the
is
minimum.
no, it at all. I am, of course, to say that when I'm providing phi, I'm in no way ascertaining it to show. But phi, I know what is phi, right? I know that had there been one, were there one pebble over here and would have been thrown straight, let's say, this pebble would have required what energy to make a show, correct, dear? To
Yes.
show itself.
Yeah.
That I know. Accordingly, were there only one electron with this material under study, I know being provided phi, it was must to show. Correct, dear?
Yes, sir.
So, based on that, the minimum energy which is required for an electron to show is certainly function of material, but we are aware of that energy. We are aware of the quantum which is required vis-a-vis that material for an electron had it been solo to show. Correct? Yeah.
Yes, sir.
Yeah. Now, what I'm coming to your question now, that providing this energy certainly in no way is cementing our position. We can't say that it is to show. You're right on that. But what if we are in odds with any collision? We are running luck. The electron is running luck. See, there are three possibilities. Let me tell you. A photon hits the electron, fine. Now, it is just possible that after the photon makes a collision, it starts moving towards the nucleus, fine. The electrons start moving to the nucleus, correct?
Okay.
So, in that case, whatever be the energy, it is not to show, correct?
Yeah. All right.
Of course, I'm not talking of energy which is beyond that nucleus to be beholden by. I'm talking of energy which is it being getting overwhelmed with. So, if I am referring to the energy which it will not be able to alienate itself from the electron, then that energy will help it to go closer to nucleus, correct?
Yes, sir.
Okay, so there is one possibility, it will not show. Possibility number two, in the pursuit of showing, in the pursuit of coming out of the object, it hits another electron. Find here? Possible?
Oh, so just 1 second. I have like two doubts here.
Yeah, yeah.
First of all, now that we have established that electrons exist as waves, how would we
Yeah.
consider light, thinking about it as a
Mhm.
particle interacting with an electron, which is a wave? And second of all, how
Mhm.
would a photon hitting an electron cause it to get closer to the nucleus? Because by definition, if an electron goes closer to the nucleus, it loses energy.
Yeah, correct. Now, if you answer to your first question, why am I advocating for light being studied as a particle? This is your first question, correct?
Yes, and how would it interact with the wave electron?
Okay. Okay. Let me ask you about an electron which requires certain amount of energy to show. I'm known to ionization potential of a material. Find here?
Yeah, okay.
IP is known to some extent. I'll be able to, with the help of IP, calculate what is the minimum energy for that electron to see and expulge. Fine?
Yes, sir.
Okay. So that energy is known to me. I write that energy E. This is the energy for the electron to get dislodged and show. Not only dislodge, to show after dislodge. Find here?
Yes, sir.
Okay. I want this energy to be provided to the electron. For that, what I do, I illuminate it. Fine.
Yes, sir.
I'm providing that energy. Okay? Rays, light, illuminated, radiance. Fine.
Yes, sir.
It's carrying energy. Wave is to carry energy. Intensity being I, correct? I is the amount of energy per unit area per unit time. We are aware of it, correct?
Yes, sir.
So wave is carrying some energy. This energy is hitting metal concern, and E, if is provided to this electron, it must try show. Even if it's not able to, there's a minimum energy, and if that electron is running luck, will show. Correct? That we know, right?
Yes.
So what is E equal to? Intensity multiplied with the area of illumination, let us say A, correct?
Yes, sir.
Multiplied with delta T the time, correct? Because intensity is nothing but amount of energy per unit area per unit time, correct? Okay. By this logic, we get delta T equal to how much? E divided by I into A, right?
Yes.
So this is the amount of time after of which this electron will get energy minimum with the, of course, running of luck to show, right?
Yes.
Okay. If you say no, it is just the bare minimum, let us take some more time, let it buy some more time, I get you more time. Let's say the time is now 2 delta t, 3 delta t, 4 delta t. It should show, right?
Yeah.
Okay. It was found, observed, that if the electron is to show, it will show immediately, else it will not. You keep it illuminated till the cows come home. Okay?
Yes, sir.
So here we're making two observations. Please be mindful of it. Observation number one, If it is to show, it shows immediately. Fine.
Okay.
That means we negate the concept of delta t per se. There'll be no delta t. Delta t will tend to zero. Subject to condition, it is to show. Getting it here?
Yes, sir.
Observation number two. If it is not to show, it will not, even if you keep it illuminated for eons. Find here?
Yes, sir.
So these observations somehow didn't conquer with or subscribe with the concept of wave. We were not able to explain it by wave domain. We were to see beyond of it. We were not able to. I'm not able to explain to myself or to anyone else why so that I require delta t, but in my case, delta t is A tending to 0. B, if is not, then it will not show per se. Let's say I require 5 kg, 4 kg, whatever, kg joule.
Hmm.
It's not showing. I provide 20, it's not. 30, it's not. So this
Yes, sir.
was the first chink in the armor. This was the first one. Now, the second one, I would ask you a very simple question. Try to answer logically. A person has locked themselves in the room. Okay.
Okay.
A person has locked themselves in the room. And the person says that if you provide 5 joule of energy to me, I will come out. Fine.
All right.
Okay. Now, what you are to do is to provide 5 joule of energy, right? For the
Yes.
person to be out. Now it is up to you whether for that 5 joule you require help of a man, 2 men, 5 men, 6 men, or 20 men. Correct?
Yes.
The person who has locked themselves has no say on the way that it is to be executed. His concern should be limited to 5 joule. Correct?
Yes.
5 joule gotten, zip your lip, come out. You required this, right?
Yeah.
And
Sure.
you got this. You don't have any say on how I am to provide you that 5 joule. But what we got to see in this case, in case of the experimentation that we are in, that if I am providing certain physical quantity, by that physical quantity I mean lambda, wavelength. If I'm providing certain wavelength, then the electron will come out. If I'm not, if I'm falling short of the threshold, it will not come out. That means it is ruling the roost. Not only it requires 5 joule, but it is also to call shots on how is that 5 joule to be provided or how the person want the 5 joule to be accorded to them. Correct?
Yes, sir.
This again was beyond the comprehension dimension wave. No, it is beyond that dimension. If I'm to get, I'm getting you this, you should be out. You have no say on which way it should be provided to you, correct?
Yes.
But what we got to see that if I'm providing certain lambda, which certainly is function of the material which is being illuminated, then it is to come out, else it is not to show. And that minimum lambda is what is called threshold, not minimum lambda, that minimum frequency is what is called threshold frequency. So if I'm providing that frequency, it will show. If I'm not, and keeping it illuminated for the number of hours I want, days, month, year I want, it will not come out. These two observations, wave theory failed to explain. Got it, dear?
Yes, sir.
So we were to look beyond. We had to see on the fact that it is just a wave. And when we had to look beyond, we'll mark our observation. The observation being immediate. If it is to get expulged, that expulsion is to take place without any lack of time. Getting it here?
Yes, sir.
What does this convey? This is possible only when there is an actual physical contact taking place, right? Yeah.
How did we deduce physical contact from this?
if you're not talking of particle being hit, when I'm talking of any experimentation, there will be some time delay, right? For example, I am relating energy with wave. Fine.
Okay.
If I'm relating energy with wave, there will be some time delay. Whatever you do, let us say I'm moving one charge very rapidly. For this transition to take place on the other charge, which was in the effect of the first charge, there will be some time delay, right? Action reaction. There's ought to be time delay. Yes or no?
Yes, sir, but for the field to be
Action reaction
established, it only
never
like
happens simultaneous, right?
so. But I mean, the field propagates at the speed of light, so it should be
It's,
pretty much instantaneous,
delta
right?
t is very small, dear. Delta t is very small.
Yeah.
Okay, but there is a value for delta t, correct?
Yes.
And that delta t is what we are in odds with. There shouldn't be a value for delta t. Delta t should be tending to zero, is what we want. So delta t tending to zero means as small distance as possible, right? Are you in
Yes.
agreement or not?
Yeah.
So for the distance to be very small, what are you trying to suggest? That if wave is what is to carry energy, whatever distance you do take, it will ask for certain value of delta t, correct?
Yes, sir. Because all that energy has to be
But that
delivered
will
over a, I mean, definite period of time.
definite period it requires, right? Yeah, my limited submission is about there should be a value of delta t which is a tad bit higher than a shy higher than substantial, sorry, a shy higher than insubstantial, correct?
Yes, sir.
Okay. Secondly, I want that person to be out. How you explain that when you provide this much, or when you provide that energy by 5 persons, by 6 persons contribution, only then I'll be out. Correct? It was all about energy.
Yeah.
If I have to provide energy, it's all about energy. Wave was all about energy, right?
Yeah.
But that didn't take place. It was not. The person was not to be out. It didn't show. The person didn't show. Correct?
Yes, sir.
So beyond, when I'm looking beyond, I've looked for why is that this is getting discrete. If it is all about continuous flow, then I should get an analog read. That is what you suggested initially, right?
Yes, sir.
It should not be a discrete read, correct?
Yep.
That was your first question. So that's a particle. What was the second one? Tell me the second one, the second doubt of yours.
Yeah, I've actually forgotten it. Um,
Okay.
I'll tell you if I recall it.
Okay, no issues. So this let us think about it, think beyond it, but there were more to come. There were certainly more to come, more than what met the eye at that moment in time. And what they were will be unfolding as we move forward. Now, unveiling the first one, threshold is what we require. We require minimum frequency. Now, when you talk of an electron, one electron will be hit by a photon. Now, what then was suggested, of course, is known to you, the postulate. You're aware of it.
Yeah.
And what they being that it carries quanta. It is present in the discrete form, which is known as packets, right?
Yeah.
Packets of energy. It is not in the continuous form. It is in discrete form, known packets of energy. Each packet contains one quanta of energy. Okay, dear?
Yeah.
One quanta of energy, and they are called photons. Correct?
Yeah.
Okay. So we came to the conclusion that okay, this photon will carry some energy. Incidentally, now see, how is the process amalgamated? We are speaking of particle nature, correct? Particle nature of certain element. I won't say wave now. We are referring to particle nature. At the same time, Vasudev, we are not making any departure from wave. We said that yes, it is present in the form of quanta, it is present in the form of particle. We named it as well, the nomenclature being photons. At the same time, what we are suggestive of is energy of each photon is directly proportional to frequency. Frequency of what? Frequency of wave to which it belongs. Getting it?
Okay, so how exactly
Okay.
do you visualize this taking place?
Yeah, exact. That is the issue, dear. We are playing as per our convenience, to be very frank and candid with you. We are playing as per our advantage. When I will be explaining to you YDSC, I'll buttress wave nature of light, because I will not be able to explain it as per particle. Getting it?
Yes, sir.
I'll not be able to. YDSC is a wave phenomena. I'll have to, at that point in time, relate it to wave phenomena of light. Are you getting it?
Yes, sir.
But when I'm to explain photoelectric effect, I'll have to succumb. I will not be able to move ahead advocating for nature wave. I'll have to find then refuge in particle. And you're aware of that both the phenomenon are related to light, correct?
Yes, sir.
So when I am to go by particle, I will go by particle. When I am to explain it only by wave, if it can, will go with the wave nature of light. They are interchangeable, dear.
Yes, sir, sure.
And to relate it is this what I write next. E is equal to watch to us, h into mu. We didn't say that they are binary. Here only we did say that energy of photon, and then I'm of course buttressing for particle nature, is related to frequency of wave to which it belongs, right? So E is equal to what to us? H into mu, where H is a constant, you're aware of it. E is equal to H into mu. This is the energy that the photon will carry. One photon will hit only one electron. Okay, dear?
Yes, sir.
A photon will hit an electron. If it is carrying an energy h mu, then what an h mu naught, let's say, then what energy the electron will come out with is certainly h mu naught minus phi, subject to it running luck. Yeah, your second question, I am coming to it. Your second question being, why will it move towards the nucleus? I did never say that it has to move towards the nucleus. I was ruling out those possibilities here. See,
Okay.
if I'm providing h mu naught and I want it to be out, then it will come out with what kinetic energy? I will simply write h mu naught minus phi. But this is possible when the electron is running luck and accordingly getting over few causes, which may see it not showing per se. And what those causes being? Firstly, if it is hit, it should not move towards the nucleus. Correct?
Yeah.
Okay. Second is, while it is trying to come out in its pursuit, it should not hit other electrons. There are myriads, correct?
Yes, sir, but the way you're describing this
Uh-huh.
leans heavily on considering the electrons as billiard balls revolving the nucleus. How exactly do you rationalize this with the wave model of the atom?
I'm not considering it to be very close to the nucleus. What did I say? It is on the surface. Let's say it's valence. It's being
Okay.
hit.
All right.
After being hit, particle, it moves towards the nucleus. Fine.
Yes, sir, but you're still considering the electron to be a particle in this narrative.
Yes, I'm considering electron to be a particle. That's the reason I said one photon will hit one electron. I'm not going by the cloud nature of electron.
Yeah. Okay.
One photon, which is a particle, will hit an electron, which is considered to be a particle here.
Yeah. All right.
Okay, and when hit, same reason, it will show the pebble. The pebble, if it's been provided with an energy more than mgh, then the pebble will come out with what kinetic energy? Is it obvious? It will come out with a kinetic energy that you have provided minus of mgh, right?
Yes, sir.
Same is the case with this. It'll come out with what energy? Kinetic energy h mu naught minus phi, where phi is called work function of the material under study, right? Yeah.
Yes, sir.
Okay. But this is the most probable one, right? This is the most probable one. This may not happen. If it is to show with the conditions being on, with it being negotiating or not being hit by any of the three presumptions, then it is to come out. Correct?
Yes, sir.
Okay. This is what is the first part of it. which is the kinetic energy, and certainly they will be asking for the drawing of the figure and all. But my question is over here slightly broad based. If it get disconnected, we'll be connecting again. Okay, Basudev, because I want to get done with was an experimentation today. Fine.
Yes, sir.
Okay. Now that experimentation, I changed the page. Is I have got a tube, vacuum tube. I have an anode and a cathode, right?
Mhm.
What I do, I illuminate it. I want electrons to get ejected. Electrons are getting ejected. Electrons are getting ejected. And these electrons are getting ejected, right? Now electrons are getting ejected, and I want these electrons to make their way to the other part. So this is emitter to me because electrons are to get ejected from a emitter, and this is collector to me. Okay,
Yeah.
it'll collect electrons. Okay, now I want these electrons to make their way up to the collector. The electrons which are getting emitted, I want them to make their way to the collector. Few which are running luck will be able to make their way on their own. Correct there,
Yes, sir.
all by themselves. You're providing energy. That energy it is coming out with. It is being hit by photon. H mu is the energy of photon, let us say. So with what energy it will come out? It will come out with energy, kinetic energy. What will that be? That will be H mu of the photon, right? Minus phi, correct? Work function, isn't it? Yeah.
Yes, so will the velocity of the electron always be directed normal to the surface of the metal?
No, not necessarily. Not necessarily. I'm coming to that. That's the reason I said, dear, running luck.
All right.
Okay, that's the reason. So kinetic energy that will come out with how much will that be? H mu minus phi, right here.
Mhm.
And if it is running luck, by that what I mean, it doesn't collide, it doesn't go towards the nucleus, it is not to come out any angle other than 90 degree. Okay,
Yes, sir.
and in its pursuit, moving from emitter to collector, also it is not to collide, right?
Yeah.
So it makes it.
All right. Just gotta rejoin.
Is recording on? Was there?
Yeah, it is.
Okay. So this is the tube. Let me draw again for you. Okay, this is what we have. It being illuminated, as we know, electrons being ejected. By electron being ejected, I'm already into some supposition, right, Vasudev? You're aware of it.
Yeah.
What that being? That being that we are beyond threshold frequency, correct?
Mhm.
Okay. So if we are beyond threshold frequency, then it'll come out, and the threshold frequency is what for us to be defined by work function, right, dear?
Yes, sir.
So what kinetic energy it comes out with, known to us kinetic energy is what to us h mu minus phi is what it is coming out with. Fine. Okay. With this kinetic energy, certain electrons are able to move across the vacuum from emitter to collector. From emitter to collector, they are able to make their way up to collector. And if they are able to make their way up to collector, electron will flow in this direction and current will flow in the opposite direction, right? Yeah.
Yes, sir.
So this is what you get, right? Now, what we are to see with advent of time, Vasudev, think about it. We are to see a flux, and that flux, not all, but not very many either, very few, a handful of them are able to make their way to collector, correct?
Yes, sir.
Majority of them, operational word over here, majority of them will fail to make their way up to collector, right?
Yes, sir. So what happens to these
And we
failed
take the
electrons? Do they
possible.
just float around with the tube?
Yes, yes, they will. Why? Had there been one, again I'll come to the same logic. Was there only one to be seen? This goes up, it becomes positive, right?
Mhm.
It'll pull it down, correct?
Yeah.
it'll make its way back, correct?
Yes.
But that is not the case. Why? Because electrons are also do move, correct? Simultaneously, this process is very passive. So in its pursuit to reach or get back, it will hit, and there will be a cloud generated, which is what we call space charge. Getting it here? Why will the space charge be generated?
Yes.
We are talking over here of a complex force, a repulsion, attraction, correct?
Mm-hmm.
Repulsion between electrons which are being ejected, and attraction between electron and the material per se, correct?
Yes, sir.
So we get collection of electron over here, which is what is being called space charge. Find here?
Yes, sir.
And this is of no use to us. Do you concur with this thought process? Yes or no?
Yes, sir.
This is of no use. Why? Because they are not partaking in formation of current. Yes or no?
Yeah.
They don't partake. They are rather hindrance to flow of current. Agreed?
Yeah.
Okay. So what I'm to get rid of? I'm to get rid of space charge. I'm to pull them to the mainstream. Fine?
Yes, sir.
Suggest me a way. What shall I do?
Yeah. I mean, this is pretty standard, right? Put a battery across the two.
Yes, exactly. I'll have to
Tubes.
pull them, correct?
Yeah. So create a
I'll have to
potential
pull them
difference,
to
and the
mainstream,
electrons
right?
will be
Yeah.
accelerated towards the cathode.
Okay. So what shall I do? I should apply a field,
Yeah.
isn't it?
Yep.
Field in which direction? This direction will do, correct?
Yes.
And to apply field in that direction, what I have to do, as you suggested rightly, I'll have to place a battery, a source.
Yes.
This will do?
Yeah.
Okay. So electron being pulled, this is what I'll have to provide. And this is what to me, this is VCE, VC minus V, correct? VC minus V. This is what I want. Okay?
So what are those?
High potential, low potential, collector, emitter.
Oh, okay. All right.
Okay? VC, correct. VC
Yes.
minus V.
Yes.
Okay. So if I want to pull more and more, if I want to pull them to the mainstream, the space charge, I want it to get denuded off. What will I have to do? What will facilitate me getting denuded off or space charge getting completely removed from as a barricade is to increase the amount of VC. I'll keep on increasing, I stand better. Isn't it?
Yes, sir.
Okay. So if I keep on increasing VC, you are in agreement, current will keep on increasing as well, right? Till the time there is present even a single space charge, right?
Yes, I'll keep increasing until it saturates.
Yeah. Uh, if there is no space charge, right there, then what will happen?
Then
If I
it'll
keep on increasing, space
attain
charge
constant
over,
value.
fine. So will the current increase thereafter?
No.
No, current will not increase. Current will be independent of VC, right?
Yes, sir.
And this is what we show by characteristic plot. I'll come to it. This is current to me, and this is VC to me. Okay. Okay. Now, reverse of it, Vasudev. Reversal now. By reversal, what I mean, what I do next, I don't want the electron, let me say, I don't want the electron, capital D, which is having maximum kinetic energy, even maximum kinetic energy to make up to collector. I want it to fail. Getting it?
Yes, sir.
It was making on its own. But I want it to stop, fall short of reaching, making up to the collector. What do I have to do? Of course, reversal of voltage, inversion of voltage, same yes or no?
Yeah. You'll have to set it up such that the energy it would spend getting from the emitter to the collector would drain all of its kinetic energy.
Correct, correct. Even if it is about to make
Yeah.
just an iota left, it should get drained. Fine?
Yeah.
In that case, what I have to do, I'll have to reverse it, correct? That means
Yes.
VC should be negative. Agreement?
Mhm.
So if I am to make VC negative, what I am to ensure that the electron having maximum kinetic energy, K maximum, should fail to make up to collector, should fail to make collector, right? Yeah.
Yes, sir.
Okay, let me say that is negative. I will first to show you the polarity. This is the polarity which I'm working at. So VC is negative to me. This is negative to me. VC being negative, where we are, let's say over here we are, and we have ensured that the electron having maximum amount of kinetic energy fails to make collector, right dear? What will be current in that case? Zero.
Yep.
Okay. I slowly decrease the negative, go to zero. What happened to current? Current will increase, and it'll be a rapid increment. Why? Because you have sea of space charge. Tell me yes or no.
Yes, sir.
So with increment in VC, what will happen to slope? Slope also will increase up to certain position. Agreement?
Yes, sir.
Then what will happen to slope? It will start decreasing. Tell me why I am sounding so glum now. Decrement.
So the sea
What
of
happened?
electrons are not there anymore. I mean, all of them are getting to the collector.
Okay, and when we are not left with any single, it is to Planck, correct?
Yeah, kind of a sigma type curve.
Okay. Yeah, it is a sigma kind of a curve. This is the characteristic curve.
Yep.
Find here? This is a characteristic curve. Now, a question over here, which is current getting saturated. I write that saturation current, I1, let us say. This is current, saturated. Okay, got it here?
Yep.
Let me ask you a question. What I do next, I increase intensity. Intensity of what? Wave. Fine. Which wave? The wave that was hitting emitter. Find here.
Yep.
If I increase intensity, keeping frequency same, or vice versa. If I increase frequency, keeping intensity same, what happened? Take one at a time.
So which one?
Take one at a time. What I do, I increase, let's say, frequency, keeping intensity same.
Okay,
Right?
then it
I'm
should.
increasing frequency.
Then the saturation current should be reached earlier on the
Okay.
voltage scale because it should take less energy to propel the electrons to reach the collector.
Okay. So what do you say about current value? Will that change?
The current value shouldn't change
The current value shouldn't change. And why so?
because the same number of electrons are being emitted. It's just easier to
How come same
convince.
over? Let me ask you a question over here. I have kept what the same? I have kept intensity same, right?
Yes.
But I have increased frequency, correct?
Yes.
Let us say initially this intensity was provided by how many photon? 5 photon. Fine.
Sure.
Now, as I've increased frequency, the same intensity will provide by 4 photon, let's say.
Yeah.
So number of photon decreases,
So come again. Yeah. What
number
did
of
you?
photon will decrease. I want 5 joule of energy or 10 joule of energy, and these were provided. This amount was provided by 5 photon. Let us say, okay, dear.
Okay.
Having what energy? 2. Is it okay? I require 10 x. Now I've doubled the energy 4 because I've doubled frequency. Correct?
Oh, okay. So what if you keep if you keep the intensity constant and you change the frequency, that results in a change of number of photons also.
That is exactly where my question lies there. I'm asking you, what about intensity? I have kept intensity same, right? But I've
Yes.
increased frequency. Fine?
Yes.
Possible? Why
Yeah.
not? Very much possible. I'll keep intensity same. I increase frequency. Possible? Yes, it is.
Okay.
So by that logic, what I come to, what the inference I come to certainly is number of photons should decrease, right?
Yes, sir.
So if number of photon will decrease, it will have a ramification on number of electron as well.
Yes. The max current should also decrease.
Number of electron should also decrease.
Yeah.
Saturation current should fall.
I'm guessing it doesn't, judging by your tone.
Doesn't you don't say by what you have read. I am asking a question. I am not going by the reading in the NCRT or any other book. I'm asking for you to grow your brain here and let me know
Yeah,
what
sure.
can be the answer.
From what you're
Yeah,
saying, yeah, it does sound logical.
yeah, correct. So where are we going wrong? Are they wrong or we are interpreting it wrong? And
Uh,
don't be judgmental over
okay.
it.
I think when we say intensity,
Hmm.
well, are we really sure it refers to like the energy output and more like number of photons? I mean, it really feels like it should refer to the
That's
former.
the whole. Very good. You are on the correct line of thought.
Oh, okay.
Frame your word. Word it. Word your thinking, please.
Okay, so what I was conjecturing is that intensity
Yeah, I'm taking that
is,
surmise. I'm taking that conjecture. Go
yeah,
ahead.
okay, so intensity depends on the number of photons, not on the total energy the photons carry
Exactly.
collectively.
Your innuendo. What are you trying to over here suggest? The innuendo is absolutely an apt answer to my question, which is what when we are dealing with particle nature, intensity is to be related to number of photon or electrons. It is related to number. We are not to take the definition what we are coming as a baggage vis-a-vis wave understanding. Got it, dear?
Yeah,
That is no more to over here work. That has lost its relevance long back. Why? Because we are not into wave nature anymore. So that definition will not hold true here. Getting it here? It
yes,
will
sir.
be related to number of photons. The moment you say intensity is being dropped, what does it mean? You're dropping the number of photon. Got it?
Yeah,
So that's in a way is an answer to the question. So what will be the effect then? Will there be anything affected over here by the change of frequency? Intensity is same, so saturation current remains same. Why? You know the reason, correct?
yeah,
Okay. What about voltage? What about reverse voltage, which we call stopping potential? Stopping potential is nothing but negative of VC. Is it okay, dear?
yes, sir.
Please be very careful. When they ask you stopping potential, you will not say -5. You will say 5.
Yes, sir.
You will
Got it.
not say -6. Uh, Getting it?
Yes, sir.
Okay. Because stopping potential will be inherently negative, correct?
Yeah.
Okay. So what will be the effect on stopping potential? Can you suggest?
I,
Simple?
I think the entire graph would be shifted left. So the stopping
Yeah.
potential
What
will
will
be
be
higher,
shifting?
and the saturation is also
Correct.
attained earlier.
Okay, so the stopping potential over here, saturation the same, right, dear?
Yeah.
Many a graph you'll be getting on these, dear. Fine, dear.
Yeah. Sure.
This for the day was there, fine. We'll be furthering it later. Done?
Yes, sir. Thank you.
Okay, thank you, dear.
Good
Take
night.
care. Good night.